Hello everyone, it's Wilson here. Today let's continue to talk about how to evaluate integral without using the FTC. So what we're going to do is that we are going to graph the integrand, right? This is the y equals absolute value x minus 3. So let's just look at this function here. This function, so y equals absolute value x minus 3, it's really just what? It's really just moving the graph of its parent function, which is y equals absolute value x without the minus 3 in there, 3 units horizontally, okay, to the right. So what this minus 3 is doing is that it's a horizontal translation of this graph. So we know that the graph of this parent function is the v-shaped graph, and its vertex is at the origin. So what we're going to do is that we are going to move the vertex 3 units to the right. So that means we have 1, 2, and 3. That means now our vertex for this function, for this absolute value x minus 3, is at this location, 3, 0. Okay, so we have this point right here. And now what are we going to do? We are going to just draw the V shape, because you know that the shape does not change, right? So we're going to plot some points just to make it easy for me to do the graphing. And so now I'm just going to just make a straight line here, and then also make a straight line here. Actually, it's a ray, right? Because we're starting from the vertex. And so now we get our V-shaped curve, which is y equals absolute value x minus 3. And so now we also need to just bound the region by using the lower and the upper limits for the integral. So we can see that the integral starts from x equals negative 2. So that means we're going to start from here. Okay, so let's just put that point here. This is negative 2. So we are going to just bound a region here by using the line x equals negative 2. And then the upper limit, which is 4. So we are going to just also cut off the graph, right? With the vertical line x equals 4. So now this integral actually represents the area under the green V-shaped line, right? Or actually, we cannot say line, and then also it's not a curve, right? So under the graph of this function, and then also bounded by x equals negative 2, x equals 4, and also the x-axis. Okay, so now what are we trying to find here? We have two regions. One of them is this yellow region right here. Okay, so one of them is this region here. What about the other region? The other region is this one. So it's this tiny triangle here. So there are two regions. One of them, I can just call this one A1, right? And then I can call the other one A2. And so all we need to do right now is to find the area for each one, and then we sum them up, and then we actually will get the value for this integral. So that will be easy because we know how to find the area of a triangle. So what we're going to do right now is that let's just look at this. A1, right? A1 is equal to 1/2 times the base, and then times the height. Okay, so now let's take a look. What is the base? The base, let's count. The base is right here, 1, 2, 3, 4, 5, 5 units, right? As you can see. So the base for this, the base is equal to 5 units. What about the height? Let's check. So 1, 2, 3, 4, 5, 5 units also. So as you can see, we have 5 units right here. So the height is equal to also 5 units. So now what? We can just plug in the 5 into the base, and then we plug in the 5 into the height, and then we can actually find the area for A1, for the triangle one, is going to be what? 25 over 2. Okay, so that's for A1. Now we also want to find A2. So A2, as you can see here, what is the base? The base is actually just 1 unit. And then actually the height is also 1 unit. So now A2 is going to be, again, it's going to be 1/2 times the base times the height for the area for a triangle. Right? So you can see that it's 1/2 times, what is that? It's 1 times 1, so you are going to get 1/2. So now, what do we have here? The integral, okay, so as you can see, the integral, okay, it's actually just A1, right? A1 is what? 25/2, and then plus what? Plus the A2. That's just 1/2. Okay, and then now what do we get here? We are going to get 26/2, so the final answer is going to be 13. You see that that's actually quite easy. We actually didn't really use the fundamental theorem of calculus. We didn't even find antiderivative of the function, and we were able to find the value for this integral. Okay, so that's it. And to help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily.